This following process is kind of a reversal of what we've discussed so far. So in this situation, we are going to figure out what size sample is required for the error bound to be a certain size. Essentially, we're going to say, hey, if I want the error bound to be 2 above and 2 below, this is how many I would need to have in my sample to keep the error bound at that size specifically. All right, remember or recall that this is the error bound formula right here. So if I were to rearrange this, again, if you're not an algebra person, that's okay. You can just write down the final result. But if we want to solve for n, get the sample size alone, we have a few things that we need to do. And there's a lot of different orders in which I could do this. I'm going to go and divide both sides. How do I want to do this? I'll multiply both sides by the square root of n. That's going to move it to the other side, right? I'm trying to get n alone here. So now I have the square root of n times e is equal to the z-score times alpha. All right, and I'm not writing the subindex on the z-score just to keep our work a little more neat. And then we could maybe divide both sides by e. Again, I'm trying to get z alone, n alone. I'm trying to solve for n. So now I have the square root of n is equal to z times alpha over e. All right, and I wanted the square or n, not the square root of n. So to undo a square root like that, you square both sides. So now I have n is equal to z times the standard deviation divided by the error bound all squared. Or another way we can write this, the way that I have it kind of officially in our notes, is the z-score squared times sigma squared divided by the error bound squared. So again, if you're not an algebra person, if you don't really care where the formula comes from, you could just write this in here. That is what n is equal to, okay? I just kind of tried to show you where it was coming from so that you can see that it's actually from something we've already discussed. All we did was isolate the variable n. So this is the sample size that would be needed to have this error bound. That capital E is the error bound that you would want. So let's just dive into the example for this in the same video. It might be a little bit of a long one. You'll just have to stick with me. We want to obtain a sample to estimate a population mean. Based on previous evidence, you believe the population standard deviation is 44.9. All right, that's sigma. Population standard deviation, 44.9. You would like to be 90% confident. That means that my z-score is coming from a 90% confidence interval, CL 0.90. So alpha was 0.10. So alpha over 2 was 0.05. All right, remember this was back where we used that normal curve to get that corresponding z-score. So from a 90% confidence interval, that's where this z-score came from. And if we go back in our notes or we rediscover it, that z-score was 1.645. Right, that was from a previous example. Towards the very, very beginning of our chapter 8 notes, if you need to go back and look at that. All right, that was the z-score that came along with that. And we want our estimate to be within 2 of the true population mean. That's our error. That's what they want our error bound to be. All right, so given this information, we want to know what is n. How large of a sample is required? What is n going to be? Well, n is equal to z squared times sigma squared over the error bound squared. All right, that's 1.645 squared times 44.9 squared divided by 2 squared. We put this into our calculator and we get 1363.8. 0.8433, so on. Actually, if I'm going to stop at 4, I'll round that 4. Fourth spot, 0.8434. Now this one would have rounded up anyways, but let's take a moment, and this is how it's going to be kind of needed to be inputted on your online homework as well. This is the minimum amount of data we can collect to make sure that we have this error bound of 2. 1,363.8434. All right. Can I have 0.84 of a piece of data? We either have 1,363 pieces or 1,364 pieces. You can't have a half a piece of data or 0.8 of a piece of data. So when you're talking about this sample size, it has to be a whole number. And no matter what that decimal is, you have to round up. Must round up no matter what. So another example, if we got 17.2 for n, that would be 18. You have to round up no matter what when we're talking about sample sizes. Okay, this is only for n. Other things we round according to that following decimal, but for n, for the sample size, we have to round up no matter what. So my sample size would need to be 1,364. Now there's an online calculator for this as well, but again, I'm going to assess you without the online calculators. So you need to know how to do this by hand. This should be one of your formulas on your little formula card. All right, let's go to that online calculator. Let's see if we can figure out which one it is. If I go to my list, my LibreText statistics calculators, I want the sample size for a mean. That's number 11, sample size for a mean. Oops. Click on it. We have sigma, E, and the confidence level to input. All right, sigma was 44.9. E, the error bound, was 2. And we wanted our confidence level to be 0.90. I put all of those in. I calculate in 1,364. All right, so make notes if you'd like about how to utilize that online calculator. You need to be able to do it by hand, so only use the online calculator if you're really confident that you're doing it correctly by hand, or if you just want to check yourself, you can use that online calculator to check yourself.